Welcome to Programming in Modern C++. We are in week 1, module 3. In the last module, we started taking a look at how to write equivalent C++ programs for simple C programs. We took examples which involved IOs, variable declaration, standard library and bool and so on, and observed that most of the times C++ gives us more flexibility in terms of the declaration, input output as well as typing, and things start getting simplified to read as well as write. So, we will continue that study in this module as well, looking into the next two important things all of us need to know in programming, that is arrays and strings. Right. So, this is the outline which will be there on the left always. So, let us talk about arrays and vectors. So, first arrays. So, here is a program which defines an array of length 4, that is 4 elements, and of type short. So, every number is short, and then it assigns values to different array locations and prints them one after the other. Now, this is a program which is, if write in C++, it remains the same. I mean, there is no difference of using fixed size array between C and C++, it is the same. Now, let us say this fixed size array could be a large one, right, and it is possible that it is fixed size because we do not know what the maximum size should be. So, we just make it large. Right. So, here is one way of writing it, where we make it we use the constant size of the array right into the code, and then add the elements and so on, assign some element, add them. That is just for illustration. That's the other option is to put a manifest constant defining the size and then use that manifest constant. This is, I mean, here both are C. It is not, you do not need C++ here, the both are C. Now, we often prefer this because if we in future need to change the size, either increase it or decrease it, then it becomes quite an exercise to dip inside the code and find out where this size has been defined, because it is not going to be as simple a program like what you see here. It could be couple of thousand lines that you have in the file, and finding out exactly this dimension, size dimension of this array has to change is a huge problem. Whereas, if we do a manifest constant, I can just simply change it here. And it also gives another advantage that often maybe number of different arrays may have their size related. I am reading 2 vectors and adding them in a third vector. I have 3 arrays and all of them must have the same maximum size. So, if I hard code, I have to do the changes in 3 places, I might miss that out, but if I put the manifest constant and use that, the change is only at one place and solutions are simpler. So, this is just talking about how to keep things better in C itself, and okay. So, let us say now we want an arbitrary sized array, because we do not know how big it should be. I mean, should I unnecessarily keep it 10,000, 100,000, how much, I have no idea. So, the one option is to declare a size, an array large enough which is greater than the size, all possible size that can have, and that can be hard coded as a maximum size, as we have seen, or declared through a manifest constant. Now, as we have learnt in C that this is not often a preferred approach if you do not really know what is going to be the size. So, what you can do, you can use a dynamic allocation using malloc. There is a C equivalent of that called new, which you will learn later on, but know that there is an equivalent of this. So, even malloc itself will also work in C++. This will be helped to dynamically allocate space at the runtime. So, at the runtime you may be able to figure out that you need this much of space. So, you allocate that sized array and proceed, but this will still not allow you to change the size while once you have allocated it. Once you have allocated, it is kind of frozen, right. So, that is the available approach that you have. So, with that let us see what how things go. Okay. So, now in C you have this manifest constant and this. In C++, what I do is I include a new thing called vector. Vector is a library, a type defined in the library, not in the language, but in the library. Therefore, I need to include the library component vector. Then I write this, where ARR is the name of the array. Vector is what I want. Vector is like a one dimensional consecutive locations. I want those locations to be of int type, and at the time of declaration, at the time of definition, I want the size or the number of such ints as max. So, you can relate that int comes here, array name is here, the size is here, and instead of this built-in array, I do this vector stuff, a particular notation, right. So, if I do that, then once I have declared that, then I can use it exactly in the same way. There is no difference. I use it in the, I have not declared it with this array notation, but I can use it in the array notation. So, nothing else changes, it is just the declaration that is different, and the same program works. So, max is the declared size of the array, max here is the declared size of the vector. There is no header included, here the vector header is required, here you declare it as you know, and here you have to declare it as vector int. So, kind of you can see that the type of the array and the type of the vector maps, syntactically in this way, right. So, the question as to what great thing we have done. I mean, it's the same thing, same index, same notation. To see the advantages, we will now have to take the next example, where we actually dynamically allocate an array. So, look at the C side, included this to get malloc, and this is what we have to do is we have to call malloc passing the size, the total size in bytes. So, where count is the number of elements that I get at the runtime, size of int is the size of every location. So, I multiply them to get the total number of bytes in the array, and the array actually is defined as a pointer to integer, because I could not have defined it as an array because I did not know the size. but as you know, due to pointer and array duality, I can use this in the array notation. Right. Coming to C++, you do the same thing. You declare, now you are not making a explicit dynamic allocation, you just declare the array. And unlike the previous time, we have not even provided a size max as we did earlier, because if I do not provide, then it takes a default size, whatever that default size is. Now, what I can do, once I have got this count which says how many elements I want, I can resize the array. I can resize the array. This is something which is very, very important, that I can change the size. So, the default say count here is 10, say suppose my default was 5, then the vector ARR will be resized to fit 10 elements. It can be resized, suppose I started with a default of 1000 and my value is 10. As I resize, this 1000 will be reduced to 10 size vector, and the remaining 990 elements will be released, because I do not need them. Rest of the code remains the same. So, couple of advantages. One is, for using malloc, you have to do the size of, and it's complicated syntax, a lot of things to be written, and then you have to do a kind of a bypass by taking a pointer and then interpreting it as an array. Here it is just straightforward, simple to write. Second and most important thing is, you can set the size by malloc only once, because this is the time that you are allocating and getting space, whereas here you have first got the array and then you are resizing it. Right. So, it is possible that even going forward, if you decide to have more elements, or if you decide that no, I do not need that much of it, you can again resize. So, at the runtime, you can change the size of the array as you need. Those who have done dynamic arrays well will also say, well, that is possible in C as well. I can do a realloc and so on. And but if you do that, yes, you can do that reallocation more or less, but then you will have to manage the entire thing of copying the original array into the reallocated array, and manage the pointers, everything you have to do. Here nothing you need to do. You just say this is a vector and resize. So, it resizes at runtime and makes your coding much easier. So, whether it is a fixed size array, whether it is a array which is fixed size by manifest constants, or whether it could be potentially a dynamically managed array size, all of that can be handled by just this vector definition, which naturally makes arrays much easier, or array like things much easier in C++. So, very often, unless it is absolutely known that this array has this much of fixed size and so on, you will be using vector to make things much easier to deal with. And mind you, the vector is as efficient as arrays are. There is hardly any overhead of using a vector over using a traditional language defined array. So, that is a big point to note, that is a big thing to learn, that I can actually do all of these in terms of C++ and make any program, because most programs will have arrays and we can make them simpler to read, write and manage by using the vectors that are available in the standard library. Next, move on to the next now move on to the next type, which is string. string we all know are heavily, I am sorry. So, strings will be manipulated in C and in C++. For in C, as you know, we have string.h. All of you know this, I am sure. And what is a C string? It is an array of character which is terminated by null, which actually is defined to be 0. So, after 0, whatever is there will not be considered. Right? And how does it become a string? It is not a string by type, it is just an array of characters, and by convention you are saying that somewhere it will have a null character, and that means the end of this stream of characters as a string. So, how does it become a string? It becomes a string by the way the different functions in string.h standard library component interprets it. So, we often do strlen to find out the length. What it does? It starts from the index 0 of this array, keeps on going till it finds the null character, and as many characters are crossed over is returned as the value of the length. Similar things are done in str cpy, str cat, str dupe, and so on so forth. So, the language does not have any support for string, nor does the library has a support as a string type as such. It just provides you a few functions and a convention of storing characters with a null termination, which makes the whole story of string, which is heavily used. Now, similar thing is provided in C++ in terms of a type which is still not in the language, but in the C++ standard library. The standard library component string defines a string type. It is a type, and it is a type with very convenient operators, like you can have plus operator to concatenate two strings. It is kind of equivalent of strcat. You have an assignment operator to do a str copy, and so on. In addition to that, you can use the C standard library string.h functions in C++ by including C string as in the std namespace. Right? So, this is the overall story of strings between C and C++. Okay. Now, let us go with concatenation of string, that is the. So, in C you have C string.h, here you have only string, not C string. If I have hash include C string, then I will actually include the C standard library header, which is strcat, strcpy and all that. I do not want that. What I want is the C++ standard library string type. So, I just include string. Now, here I have initialized an array with these characters, initialized another array with these characters. I have just for the purpose of illustration, I have shown two ways of initialization, both of which are available in C++ as well. And then I declare an array which should be the concatenation of this hello followed by world. Right? So, to get there, what do? I copy the string 1 into str, which overrides everything in str and make it str1, and then I do strcat str2, which means after str1 remove the null terminator, put the characters of str2 with the null terminator, so that you get the whole string. Very simple algorithm. You all have written this, you know. In C++, this reduces to simply saying this str1 plus str2 means concatenation, right? And then what you achieved in terms of strcpy and strcat is putting the values in that target array str. That is simply done by another operator, assignment. A string is a type here. So, it supports plus to mean concatenation, it supports assignment to mean overwriting a string, and the name of the type is string. So, it gives a huge advantage in terms of using this. So, if you compare, there is a need for string.h in C, there is a need for string, again mind you not C string. C string is an array of characters, whereas string is a data type, which internally may keep a C string. We will talk about that later, but so far as use is concerned, you can just treat it as a data type. String concatenation is done with strcat, need to copy into str, and str must be large enough to fit the size, and the user has to take care of all of that. Here all that you need is like addition of int. You do not have to bother what is the size of str and so on. Str, after the concatenation, str is being initialized with that concatenated value. So, it will be initialized with a proper size. Everything is taken care of one line. Right. So, you can see, when you have programs where you will have to do lot of string manipulation, how easy it becomes when you deal with the string type. Right. So, that is a big plus so far as C++ is concerned. Now, besides this plus, obviously we have talked about the assignment operator, which is the string copy, and you can compare using less than equal to, less than, greater than equal to, greater than, and so on operators, which are equivalent of strcmp in C. So, several of these can be done as a part of the type itself. So, here, I mean, this is not for kind of memorizing, but this is just to highlight, to connect you to what are we talking about. This is your string.h standard library in C. So, these are the different functions, and on the rightmost column I have put yes to mark that these are the functions which are more commonly used, and as a C++ programmer you must be familiar with those. So, for example, you have things like memcopy, which is very common, memmove. These are actually not exactly string operations, but very useful. You can copy any chunk of memory, buffer, and so on. Then you have strcpy, which you concatenate. Then you have comparison. You have strchr, finding out a character, finding out a token, the null macro itself, which sets to 0, size t, which talks about integer size and so on. Other functions are also important here, but these are some of the commonly used, frequently used functions, which you kind of must know by use. Others you can look up further as and when needed from the user documentation. I need to erase this. Okay. Now, I am showing you the string in the C++ string library. Now, as we will see that this is a type. So, it will have a constructor destructor, which we will understand over a period of time, but it is just to say that you can take a C string kind of string and initialize to create a string object. It does support assignment, and it gives certain things called iterators. They are nothing but iterators are nothing but ways to go over a string. So, if you have a string here, and so these are the different locations in the string, you can say that I put a marker here, and I can say I can put a marker here. So, this is the beginning and this is the end. of a simple iterator. So, I can say that I want to iterate from begin to end, which means exclude the end, but start from begin and go up to, but not including the end, right. So, this gives you, I mean, it is kind of a higher level for loop you can think of. We will certainly explain this more, but these are common structures that you have in C++ standard library. So, you have very varied forms of these iterators on that type. You can go from begin to end, you can come up from reverse, that is left to right, right to left. You can do it for constant arrays, you can do constant strings, you can do it for non-constant strings, and so on and so forth. Okay. Okay. So, there are some more of what string type has, and on the rightmost column, and this is something which you will typically not find in regular documentation. In the rightmost column, I have tried to map the corresponding C function in the string.h wherever it is there. In some cases it is there, in some cases it is not there, because you can do things which are not, like resize. You cannot resize a C string, but you can resize a string object. Okay. So, I have tried to give those mapping. These are for your references, again not to memorize right away, but as and when you will start using lot of strings, you can find this. But the entire thing that I am trying to show is string is a type in C++, which is not only easy to use, very powerful, and it has features which go way beyond what your typical C string in string.h with its functions can do, but you are still free to use some of those functions if you really need to. This is continuation of that same list, and you can do a lot of things like appending, like putting a character at the end, so on and so forth, lot of stuff. So, this brings us to the end of this module, where we have primarily focused on handling of arrays and the convenience of using vectors in C++, which is equally efficient and can be seamlessly used in the same form, whether it is fixed size, whether it is small, whether it is large, or whether it is dynamically runtime resized. All of these can be handled in the same syntax and the same structure using vectors, which is not so in C. You have to keep track of the size from the static time, or do a explicit complicated dynamic allocation using malloc and all that. And further, we took a look at the string type or string operations in C and C++, when we saw that C++ standard library defines a string type as string component in the standard library, which is very useful and lot more compact than our C string equivalent in the string.h. Thank you very much for your attention, and we will meet in the next module.